Hello, my name is Josh Reingold, and this is my report on the Constant Velocity Lab for Physics 1. The purpose of this lab was to analyze the movement of an object that has a constant velocity using Tracker, create a predictive computational model that projects the movement, and then compare the two sets of collected data. The model used in this lab was created using GlowScript, and it is intended to show how an object in motion maintains a constant velocity when not acted upon by outside forces. From the data collected, I determined that objects generally maintain constant velocity and adhere to the projected model, but it is very challenging to eliminate all outside forces, such as the force of friction. I chose to use a roll of duct tape as the system to conduct this experiment because it has large enough mass to not change direction during the experiment. The surroundings I picked was a clean, flat surface to help mitigate any external factors. I applied an initial force to the tape by pushing it and then let it roll across the floor to the left, videoing the motion. I imported the video into Tracker and adjusted the time frame to when the tape had the most constant motion. I chose to put my axis at the center of the tape roll, with the positive x direction to the right and the positive y direction upward. This meant that the tape was traveling in the negative x direction during the experiment. I used Tracker to establish 48 position data points, one for each frame used in the experiment, and imported this data into a Microsoft Excel document. To create the predictive algorithm, I imported the starter code provided into GlowScript. From there, I adjusted the necessary parameters such as delta t and the velocity vector so that it more accurately predicted the motion of the tape that I used in my experiment. I modified the model several times to get it to predict the motion as well as possible. After running the final program, I imported the data results into the same Excel document as the tracker data. Using both the observed and predicted data, I created the line graph displaying both sets of data with the same scale. Theoretically, the observed data should perfectly match the projected data because position update formula shows that without any external forces, the object's position will change constantly due to the initial constant velocity, and therefore this is the correct model to use. However, while this graph showed that the observed and predicted motion were nearly identical for the first second, the observed data showed the tape slowing down slightly during the rest of the time period. This is most likely due to the external force of friction between the tape and the ground, which created an acceleration and therefore a slight change in velocity, causing the two datasets to diverge. If I were to have flipped the axis when analyzing my video data with Tracker, then the tape would have been moving in positive x direction rather than the negative. I would have adjusted the GlowScript predictive model accordingly, and it would have affected the graphical depiction by orienting the line upwards above the x-axis rather than downwards below it, reflecting the data perfectly across the x-axis. The ideal net force for this experiment is 0, which the predictive algorithm assumes is the case. In reality, there are several forces acting on the object which don't always sum to 0, causing imperfections in the experiment. The forces acting on the object during the experiment are the initial force provided by the push, the gravitational force pulling down on the tape, the normal force the floor exerts pushing up on the object, and the frictional force pulling back on the object. While in motion, the gravitational and normal forces cancel each other out, which would set the total net force to 0, if not for the frictional force. In summary, this lab nearly demonstrated the constant velocity principle for an object moving in a straight line. The total net force on the object was near 0, causing the observed and predicted data to be nearly identical. However, because there was a frictional force acting on the object, the data began to diverge after 1 second.